Consider the matrix A right on the board. How can we evaluate the inverse of matrix A? In this video tutorial, we are going to find the inverse of matrix A by the use of the elementary row operation method. To use this method, we will need to augment matrix A with its identity. Since matrix A is a 3 by 3 matrix, then its identity will be given as this: 1 0 0 0 1 0 0 0 1. Perfect. Augmenting matrix A relative with its identity, then we have a larger matrix, which will be of this form, where matrix A, element in matrix A will be presented first, then element in the identity matrix of A will be presented in the other cases. Now the 1 0 0 0 1 0 0 0 1. Perfect. So this is what we need to determine A inverse. So the D is that we want to express the matrix we have at the left hand side to be in form of the identity matrix. And in that process, at the end of the day, whatever matrix we are left with at the right hand side is the inverse of matrix A. And that's the basic idea behind the use of the elementary row operation in finding the inverse of a 3 by 3 matrix. Perfect. So now, what are the steps that guides us to find the inverse? So let's begin with that. So I'm just going to bring this up, or let me just say write it. 1 2 1 2 minus 1 2 1 1 minus 2. Then I have 1 0 0 0 1 0 0 0 1. Perfect. So now the goal is that we will first express the matrix at the left hand side as the upper triangular form of a matrix. And the upper triangular form of a matrix is a kind of matrix whereby all the elements below the leading diagonal is 0. So our goal is to turn these 3 elements to 0. Having done that, then we will express the matrix again in the lower triangular form of a matrix. And that what that means makes sense is that all the elements above the leading diagonal will be 0. So which means the 2, 1, and 2 will have to also be 0. Then lastly, that we need to consider doing is that we have to make sure that all the elements in the leading diagonal is 1. Once we can do all these 3 steps, then we will be able to have our final answer. So let's begin. The first one is to express it as the upper triangular form of a matrix. Now the first question you might want to ask, which of the elements should we make to be equal to 0 first? And the answer is to start from this element 2. Always start from that position. So how can I make 2 to be 0? You have to be very, very careful. So this is what you want to keep in mind. The fact that 2 is along the first column, then you have to operate it with the element in the first row. Now that's one thing. Okay, to know the row that you'll be making use of when dealing with the operation, just observe the column that the element you want to change correspond to, or the column that the element you want to change falls to. I hope you got that. So now, having done that, you want to make sure that you set the operation in such a way that the row you are making use of is coming last. What am I saying next sense? Yes, I want to make 2 to be 0. and I know that it is at the second row. So I want to change all the elements in the second row, add 2, such that this one will be 0. So I don't really care about the rest, but the main goal is just to make this one 0. Now, I want to do it in such a way that I'm relating it with the first row. Now, how can I make this to be 2 such that I will now be able to subtract it? I will be able to subtract this one from it. I can set that to I1. So I have 2 I1, then minus I2. By the time I multiply 2 by 1 and I subtract this from it, it will give me 0. I don't really care about what the answer to the rest will be. The main goal is just to have this to be 0. I hope you get that. Now, if you should observe, the row I'm solving for is the one coming last. That's what I want you to put in mind. The row that you are solving for will be coming last, while the row you are making use of will be coming first. So you have to set up the operation. Either you have to use addition, subtraction, or you have to multiply a particular scalar with any of those rows. You just have to make sure that the rows are arranged in the regular pattern. The one you are making use of is coming first, and the one you want to convert is coming last. Please, it's very, very important. Okay, so that you won't get stuck along the way. That's the process. That's the function of you doing that. You don't want to get stuck along the way. You don't want to get confused. You don't want to convert a particular element to 0, and along the way, that element turns to be a number back. That can cause a really big problem. Perfect. So now, let's do the operation. The new matrix we'll be having now will be 2 times 1 minus 2. That will be 0. First, let me write the element in row 1 and row 3, since those elements will not change. So I have 1, 2, 1, 1. Okay, let me write that properly. 1, 0, 0, 1, 1 minus 2, 0, 0, 1. Okay, now we said 2 times 1 minus 2. So that will be 0. So 2 times 2, I'm multiplying this with each of the elements in the first row. That's how it works, okay? 2 times 2, that's 4 minus 1. Okay, so when I have 4 minus 1, that will be 4 plus 1, which will be 5. Okay, so I have 5. Now, 2 times 1 minus 2, that will be 0. I hope you are following the pattern. You now complete this. You will have to make sure you do the operation for all the elements in that row in the augmented matrix. So 2 times 1 minus 0, that will be 2. 2 times 0 minus 1, that's 0 minus 1, which will be minus 1. 2 times 0 minus 0, that will be 0. Perfect. So this is the new matrix we are having, and the next main goal is to convert this element right here to become 0 as well. Okay, so I'm using this other part to do that. So let me use a red color for it this time around. Okay, let me write the operation first. So since the main goal is to convert this to 0, what operation should I use? Now you notice that this one is still at the first column. So definitely we have to operate it with the element in the first row. I hope you grab that because it's at the first column. If that element you want to convert to 0 is at the second column, you will operate it with this element in the second row. If it is at the third column, you will operate it with the element in the third row. That's the pattern. So I want to convert the element in the third row. Actually, you can see it's actually along the third row, though it is still in the first column. Okay, now I want to convert the element in the third row, the first one, to be 0. Now we have to operate it with the element in the first row. Now you can see that things is very straightforward, because I can just say this minus this, and now we have 0. So definitely, since the operation I'm making use of will come first, that is R1, Then the operation I want to convert something within it will come last, minus arg3. And that's just it. So if we subtract this and this, you can see that we definitely have 0. And you can see how I actually set up the row operations. Perfect. So let's do the math. Okay, I'm using the red color for that. So now this element in the first and second row will not change. I'm just going to write them back. 1, 2, 1, 0, 5, 0. Then I have 1, 0, 0, 2 minus 1, 0. Now let's do the operation. 1 minus 1, that will be 0. 2 minus 1, that will be 1. 1 minus 2, that will be 3. 1 plus 2, and that will be 3. I hope you got that. Okay, so I have 3. Now I will have to complete it. 1 minus 0, that will be 1. 0 minus 0, that will be 0. Then 0 minus 1, that will be negative 1. And that's it. And I have that to be set up. Perfect. Now, the goal is to convert this to 0 as well. Now, the case has changed. This one is at the second column. So I will have to operate it with the element in the second row. You can see the pattern. So I want to change the element that is still at the third row. Okay. And to change it, I want to operate it with the element in the second row. Now, what operation can I set up that will make me to compare 5 and 1 to connect them, and at the end of the day, they will result in 0. Now, since element in the second row has to come first, I can set R2 minus 5 R3. You can see the element the row I'm solving for is coming last, and the row I'm making use of is coming first. So why did I multiply R3 by 5? Because doing that, it will make these two elements to be the same. And by the time I find the difference, it will result in 0. There's no a particular way you need to know or use to get the scalar to multiply or to know the operation to use. You'll be the one to just imagine that and think critically on the best one that will work for you. I hope you get where I'm going next. So now let's continue. So we can do the operation. So we are subtracting 5 arg3 from arg2. arg1 and arg2 will not change all the elements. So I'm writing them back. 1, 2, 1, 1, 0, 0, 0, 5, 0, 2 minus 1, 0. So now let's do the math. So we are subtracting 0 minus 0, that's the 0. Now 5 minus 5 times 1, I will see that that will result in 0. 0 minus 5 times 3, that's 0 minus 15, which will be minus 15. Then we have 2, right? This is 2 minus 5 times 1, that will be minus 3. 2 minus 5, that will be minus 3. Okay, how did I get that? This is the 2 element in the second row. This is the element in the third row. It will be 2 minus 5 times 1, which will be 2 minus 5, which is 3. Minus 3 typically. Okay, that's how I got that one as well. Okay, now let's continue. Minus 1 minus 5 times 0, that will just be negative 1. Then 0 minus 5 times minus 1. So that will be 0 minus 5 times minus 1. So if I multiply this, we should end up with 5. So that will just be another 5. And that is our new matrix. Now, with this, we have finally convert the matrix at the left-hand side to be in the upper triangular form. Now, let's try and convert it in the form of the lower triangular form. So we can do the next step. Fortunately enough, this one has already been converted to 0. But if at all it is not a 0 element, then you start from it. You start from here, then you move upward this way. That's the pattern, that's the logic. If you're starting from here, you move this way. While we're starting from here, you move this way. Okay, that's it. So fortunately enough, this has been 0. We can start from this one. Now this one is at the third column. So if I should ask you, what row are we operating in with? Definitely perfect. We'll be operating into with what? The element in the third row, since it is at the third column. Okay, so now how can we set up the operation? Don't forget it is still at the first row. So the new element in the first row, R1, will now become R3 plus 15 R1. You might be wondering, why did I do that? You can see this one is minus 15 and this one is just ordinary 1. How can we operate these two numbers together that will result in 0? Minus 15 and 1. So if I leave this one as it is and I tend to multiply this one with 15, minus 15 and 15. By the time I add these two together, they become 0. So that's why I'm using this operation. R3 plus 15R. I hope you got that. The basic idea is just that. Just note, after you have figured out the rows that you'll be operating with relative to the column, then check those elements. It is 1 and 15. How can you make them to be 0? Okay, how can you make it to be 0? Just the question you want to answer. I hope you got that. So now let's do the operation. Now we have R3, which is 0 plus 15 times 1, that will be 15. Okay, let me first of all write all the elements in the rows that will not change. The element in the first row, the first row will change, is the one we want to change. The element in the second row and third row will not change. That will be 0, 5, 0, 0, 0, minus 15. Then we have negative 3, negative 1, and 5. Then 2, minus 1, and 0. Now let's do that. So 0 plus 15 times 1, that will just be 15. Then we have 0 plus 15 times 2, that will be 30. Now negative 15 plus 15 times 1, you will see that will be 0. Perfect. Now let's continue with that. 2, okay, it's negative 3, about negative 3 plus 15 times 1, that will be positive 12. That's 12. Negative 1 plus 15 times 0, that will be negative 1. Then 0 plus 15 times 0, that will just be 0. I hope you got that. So that is the element of the new augmented matrix. We are not through. The next thing is convert this 30 to 0. Now, what column does 30 fall to? Notice that 30 is at the second column. So definitely we are to operate it with the element in the second row. Since 30 is still at the first row, so the new element in the first row will now be equals to what? Let me ask you that question. How can we set up the operation? Okay, now the operation we are working with is R1 that we want to convert its element, and we are operating with R2. So what should we do? How can we compare 30 and 5 to make it 0? Keep in mind, R2 has to come first, followed by R1. So whichever operation you want to use, either plus or minus, it has to be R2 minus R1 or R2 plus R1, regardless of how we want to use it. So what do you think? Now, what if we multiply R2 by 6, 6R2, then we now subtract R1 from its ordinary R1. That's just R1. You can see that 6 times 5 will be 30, And if we subtract 30 from 30, that will be 0. So definitely that can absolutely work. You get the pattern. So you'll be the one to determine the operation that will work best. So we are using 6R2 minus R1. Perfect. So let's do the operation now. So the element in the second and third row will not change. We have 0, 5, 0, 0, 0, negative 15. Then we have 2, minus 1 and 0, negative 3, negative 1 and 5. So 6 times HAG2, that's 6 times 0, minus 15. That will be negative 15. Perfect. Now 6 times 5, that's 30, minus 30. That will be 0. Incredible. 6 times 0, that will be 0, minus 0. That will be 0. Perfect. 6 times 2, minus 12. That will be 12 minus 12, which will be indeed equal to 0. 6 times negative 1, that's negative 6, minus 1. So what would that be? Negative 6 minus 1. That will be negative 6 plus 1, which will be negative 5. Perfect. So I have negative 5. 6 times 0 minus 0. That will just be an ordinary 0. Perfect. So now we have the matrix to be in the upper and lower triangular form. I think there's a mess up over here. We said R3 plus 15 R1. At this point, R3 is 5. 15 R1 is 15 times 0. And that's to be the new element in R1. So that will be 5 and not 0. It should be 5 and not 0. It should be 5. That will be 5. Perfect. So this will be negative 5. That will be negative 5. Why is it going to be negative 5? 6R2, that's 6 times 0, which is 0, minus 5. So that will be positive 5. It will now result in positive 5. Now, very good. It will result in positive 5 now. I hope everything is intact now. So let's move on. The next thing is just to make all these elements to be 1. So what we are going to do is to divide the first row by negative 15, the second row by 5, the third row by negative 15 as well. So we can set that R1 is now 1 over negative 15, the new and the former R1. R2 is now 1 over 5 of the former R2, and R3 is now negative 1 over 15 of the former R3. And doing this, we have the following augmented matrix: negative 15 over 15, 0 over 15, to make it negative. So this is negative 2. Then we have negative 0 over 15 divided by negative 0 over 15. Will this space be enough? Or I should just divide everything direct? Let me divide everything direct so that I don't think this space will be enough. So negative 15 over negative 15, that's just 1. The zeros will be zeros. Then 0 over negative 15 is the 0. Negative 5 over negative 15, that will be positive 1 over 3. That will just be 1 over 3. Now, positive 5 over negative 15, that will be negative 1 over 3. Perfect. Now, 0 divided by 5 is 5, 0 divided by 5 is 5. And 5 divided by 5 is 1, that's 0, 1, 0. 2 divided by 5 will still be 2 divided by 5. Negative 1 over 5, negative 1 over 5. 0 divided by 5 is 0. Perfect. Now, we are dividing this by 15. This 2 will still be zeros. 0, 0. Then this is negative 15 divided by negative 15. That will be 1. Then negative 3 divided by negative 15. That will be 1 over 5. Then negative 1 divided by negative 15. That will be 1 over 15. And lastly, we have 5 divided by negative 15. That will be negative 1 over 3. So this matrix right here is the inverse of the matrix A. So the final solution will be 0, 1/3, negative 1/3, 2/5, negative 1/5, 0, 1/5. Or we can see that 1 over 15, then negative 1/3. And that is our final answer. Hopefully you find this content helpful. It's actually thick more than I expected, but I hope you will find it understandable. Thanks for watching. See you guys in the next video. So here's an exercise for you. You can try and put this in practice. Try and find the inverse of the matrix by applying everything I taught you in the video. So try and find the inverse of the matrix B. Feel free to share a solution in the comment section below. Thanks for watching once again. See you guys in the next video. Bye for now.